Hello everyone, the power of pi, and today we're going to be looking at a nice digit sum problem from the 2007 AMC 12A. So for each positive integer n, let s of n denote the sum of the digits of n. For how many values of n is it true that n plus s of n plus s of n is equal to 2007? So the first thing I made was an observation. I know that the number n and the digit sum are both congruent modulo 9. So n plus s of n plus s of n will actually be congruent to n plus n, since s of n is congruent to n, and s of n is congruent to s of n, which is in turn congruent to n. So this is equal to 3n, which is congruent to 2007 mod 9. If you sum the digits of 2007, you get 9, which is a multiple of 9, so this is actually 0 mod 9. So we can immediately conclude that n must be congruent to 0 mod 3. It must be a multiple of 3. So now let's do a little bit of bounding. So the first thing I would think of is, if n was, say, like a 3-digit number, that'd be absurd. If n was 3 digits, then s of n is at most 27. That equality happens when n is 999. And then s of n is at most 10. And that happens when n equals 19. So s of n plus s of n is at most 37. And then there's obviously no 3-digit number that when you add 37, you get 2007. So n cannot have 3 digits. So n must have 4 digits. It cannot have 3 digits or lower. So n must have at least 4 digits, or exactly 4 digits. So in this case, let's employ similar logic. So s of n must be less than or equal to 36, and s of n must be less than or equal to 11. That's when n equals, for example, when s of n is 29. So that means s of n plus s of n is at most 47. That implies that n is at least 1960. So that's a good bound. Now let's just do a little bit of casework. So we've established n is 19ab, where a and b are digits, such that a is at least 6. So n plus s of n plus s of n, this is equal to, n is 1900 plus 10a plus b. S of n is 10 plus a plus b. And s of n is s of 10a plus b. So this is 2007. So therefore we have 11a plus 2b plus s of 10 plus a plus b is equal to 97. So obviously the left-hand side is 97. And furthermore, that means a must be less than or equal to 8. If a is equal to 8, then our numbers have the form 19.8b. Therefore, b must be, in order to make this a multiple of 3, as we discussed, 0, 3, 6, or 9. Let's just test each of these. So if this is the case, a is 8, then we have 2b plus s of 18 plus b is equal to 97 minus 88 is 9. So b is equal to 0. We can test that s of 18 is indeed 9. So 1980 is actually a winner. If b is equal to 3, again, we'll have s of 21 is equal to 3, which is indeed a winner again. So 1983 is good. B is equal to 6. For anything b greater than or equal to 5, this will never hold, since 2 times b is greater than 9. So that takes care of that case. What about when a equals 7? What about a equals 7? For a equals 7, it's a similar kind of thing. If we go back to this thing over here, we have 2b plus s of 17 plus b is equal to 20. So now again, numbers of the form this. So b is 17, 1, 4, 7. So b is equal to 1. We get s of 18 is equal to 18. That's not true. B is equal to 4. We get s of 21 is equal to 12. That's not true. And b is equal to 7. We get s of 24 is 6, which is true. So 1977 works. So now let's just try when it's 1960 something. That means B can be 1516, so it can be 2, 5, or 8. And in that case, we have 2B plus S of, this is when A is equal to 6, so 16 plus B is equal to, when A is equal to 6, this becomes 66, and if you subtract, you get 31. So this already seems kind of ridiculous, but let's just see. S of 18 is equal to 27, that doesn't work. And then when it's 5, S of 21 is equal to 21, that doesn't work. And when it's 8, S of 24 is equal to 15, that doesn't work. So we've found 3 solutions so far, 1977, 1980, and 1983. So now let's just test when the second case, when N is 2000 something, 2000B. So let's just test 2000. That'll be 2000 plus 2 plus 2, that's 2004. And then for 2001, it's 2001 plus 3 plus 3, which is 2007. That's good. So N equals 2001 works. And if we go greater than 2001, it's easy to see that it's an increasing function. So equality will never hold again. And in summary, we have found 4 values: 2007, 1977, 1980, and 1983. So 4 values, and that's option B. Make sure to subscribe, like, and be ready for the next video.